Hey guys, in this video we're going to talk a bit about the chain rule. We're going to introduce it and talk about the idea behind it. So the chain rule works as follows. If you have a function f of x that's actually equal to a function of another function of x, so for example f of x equals y of u of x, then the chain rule tells us that actually f prime of x is equal to y prime of the point u of the same value x times u prime of x. In other words, u differentiated at the point x, and then the function y of u differentiated at the value u of x. So that's what the chain rule says. If you're not familiar with what what's going on here, a function of a function, what the heck is that? Let's take a quick look at that. So example, let's take f of x equals x plus 2 cubed. X plus 2 cubed. And then in the middle, we can make x plus 2. We can call that u of x. U of x. So that can be the u function. And then y, the function y of x, we can let equal, so u of x equals x plus 2. Let's let y of u, rather, y depends on u, not x, y of u equals u cubed. And it always makes me laugh whenever I say u cubed, because I was teaching one time in China and I doing some work and I wrote u cubed on the board. I was like, so guys, u cubed. And then this Chinese kid interrupted me. He's like, no sir, you're cute. I thought that was a really funny one. Okay, anyway, back to chain rule. So what the chain rule tells us is that for f of x equals x plus 2 cubed, we can actually rewrite this as y of u of x, where y of u is equal to u cubed and u of x equals x plus 2. All right, now let's talk, let's talk why the heck this thing would happen. So why would it be the case that if you do have f of x written as y of u of x, why on earth, when you differentiate it, can you just multiply the two derivatives of the functions? That seems kind of strange. Let's take a look at why that's the case. All right. So to do that, we're going to draw a couple of diagrams here. First one, it's going to be a function of y. It's going to be a function y of the variable u. So normally we put the x on this axis, but this time our y is going to be a function of u. And that function will be, should be a straight line. Sorry if it's a bit wonky. This is going to be y of u equals 3 times u. And of course, we know from the section on lines that for y of u equals 3 times u, we know that this means as u increases by 1 unit, this means that y increases, as u increases by 1 unit, not by u units. As u increases by 1 unit, we know that this means that y increases by 3 units. And that's true for any u we like. So that tells us that y prime of u is equal to 3. And it doesn't matter what value of u we choose. Similarly, let's draw another function. So this one is going to be our u. And yes, this u and this u are the same. So it turns out u is actually going to be dependent on another variable, x. And the function we'll use here will say u of x is equal to 1/2 x, 1/2 of x. So what that means is that as x increases by 1 unit, I use red. As x increases by 1 unit, u increases by 1/2 of a unit. So that's pretty important, because now we're going to make an observation. Well, if we have that f of x, which I'll write in red at first, f of x is equal to y of u of x, then f of x is equal to, well, y of u is 3u, and u of x is half x. So y of u of x is going to be 3, and then we put u of x in. So 3 times a half times x, and 3 times a half is 1.5, so it's going to be 1.5x. 1.5x. And that's a line as well. And so we can see immediately that actually f prime of x is equal to 1.5. But anyway, let's go ahead and make our observations that we were going to make first. So as x increases by 1 unit, so x increases by 1 unit, what happens to u? Well, as x increases by 1 unit, u increases by half a unit. So as x increases by 1 unit, u increases by half a unit. And so finally, y increases by how much? Well, if y of u equals, so if y prime of u equals 3, that means that y increases by 3 units for every 1 unit u increases by. And that's what the gradient of this line means. So y increases by 3 units for every 1 unit u increases by. But since u has only increased by half a unit, we should actually multiply 3 by half. And that will tell us how much y increases by. So y increases by 3 times a half, which is equal to 1.5 units. And this 3 is y prime of u times this half, which is u prime of x. And, well, along this axis here, this is kind of the final output of the function, right? This is the final output of the function. So we start out at x, we put x into u, and then we put u into y, and this is the thing that comes out. So actually, however much y changes by is how much f changes by, since f is kind of the result of this function. So actually, this is equal to f prime of x. And f prime of x is therefore equal to 1.5, as we already knew. And that's kind of why the chain rule works, because what we're saying is when we've got a function of another function of an input variable, well, we want to see when this input variable increases by 1, how much does the second, the middle function increase by? And based on the incremental amount of the middle function, how much does the final function increase by? And that's why we got to multiply 3 by a half. That's where these two guys come into play. And so that's why we got to multiply the change in y with respect to the middle variable with the change in the middle variable with respect to the final variable. So that's what's going on there. Okay, I know that I used lines, and lines are kind of a simple example because we got all kinds of weird functions, but actually the same idea extends to curves. The same idea can be extended to general curves. So let's draw a picture here. So this is u, this is y, and suppose that I don't know, y of u looks something like that. So this is y of u. And then let's draw another function for u of x. Maybe it looks something like that. Well, let's first take the arbitrary value little x. So if I draw this tangent line, which is nearly flat in this picture, so if I draw that tangent line, then well, it has gradient u prime of x. So if I draw a little gradient thing, as x increases by 1, u increases by u prime of x along that tangent line there. And then, well, of course, this is the value u of x, let's not forget. This is the value u of x. And then if I plot for the value u of x, if I go ahead and draw a tangent line there, then as I go across by 1 unit in the u direction, my tangent line is going to increase by y prime, y differentiated at the point u of x. And hence, as x increases by 1 unit, u of x at this particular moment, u of x is increasing by u prime of x. And so at the point, again, at this particular moment, as u of x increases by 1 unit, the tangent line is increasing by y prime of u of x. And so as x increases by 1 unit at this moment, to find out what the slope of the tangent line is relative to the variable x, we better multiply this guy here by this guy here, because that's going to tell us how much it's increasing in total. And therefore, if f of x is equal to y of u of x, remember f and y don't have to be the same functions. The output of f is still measured on this axis here, but they're almost always different functions, because y is defined as the function of the variable u. So don't always assume that they're the same function. Anyway, if f of x is equal to y of u of x, then we must have f prime of x is equal to this guy here times this guy here. Because as x increases by 1 unit, u of x increases by u prime of x. And therefore, at this moment, as u of x increases by, well, u prime of x, then y increases by y prime of u of x times u prime of x. So f prime of x is equal to y prime of u of x times u prime of x. All right, that'll do for now. Thanks very much for watching. In the next video, I guess I'll do a more formal proof of it, and then maybe a video after that on some examples. Thanks very much. Take care. Bye.